So next we will discuss the surface area of revolution, which is formed by rotating the given curve about the y-axis. So suppose the curve now is given to be x is equal to f of y, and we'll rotate this curve about y-axis from the limits y varying from c to the point d. So the surface area in this case would be given by this particular formula. So here what we have done, we have replaced this x and y with themselves. So wherever you were having y, we now have x, and we are now performing this integration with respect to the coordinate y. So its limit now varies from c to the point d. Moreover, if the curves that is given in parametric form, so suppose the equations are same, x is equal to f of t and y is equal to g of t, but now they are revolved about this y-axis. So in that case, the surface area is given by integration varies from t1 to t2 about t, and then we have f 2 pi into x here, and what is the expression for x? That is f of t, and this thing is the same. And if you have polar curves in the form of r is equal to f theta, so here instead of y, the expression for this x was r cos theta, and for y it was r sin theta. So we have, instead of y, we have the value for x here, and this term is the same. So these are the formulas. So next let me discuss one question with you. The question says, find the area of the surface of revolution which is generated by revolving about y-axis the arc of this curve. So now this curve is given to us, x is equal to y cube, and the limits are given from y varying from 0 to 1. So what would be the surface area? The surface area that would be calculated by performing integration over the limits of y, and they are given to be from 0 to 1. So integration where y varies from 0 to 1, and the formula is we have 2 pi and the value of x. What is the value of x here? X is given to be y cube, and then we have square root 1 plus dx divided dx by dy whole square, and integration is being performed with respect to y. So this is what we have to do. Now we have x is equal to y cube, so what would be dx upon dy? So it would be 3y square. So we can substitute this quantity here in this expression. So we would have the corresponding area as area that is equivalent to integration from 0 to 1, 2 pi y cube, and then 1 plus the value of dx by dy is 3y square. So we have to take its square and the square root of this whole quantity and dy. So you could open up this brackets, from this integration 2 pi would be constant, so it would be brought out from this bracket. So we have y cube square root of 1 plus 9 y raised to power 4 dy. So this is the expression that we have. So how can you perform its integration with respect to y? So what you can do, you can substitute this quantity as some other quantity. Say I am substituting 1 plus 9 y power 4 as some other variable, say m, right? So now when you differentiate this, you will have 36 into y cube into dy by dm, that is equal to 1, or you would have the value of y cube dy that is equal to dm divided by 36. So with this substitution, what do we have here? 2 pi as such, integration 0 to 1 as such, the value of y cube dy that is equal to dm divided by 36, and the value of this quantity is m. So we have square root m with us. So now we can very easily perform this integration. So its integration would be m raised to power 1 by 3 divided by, this power is 1 by 2. So when you integrate it, you will have the power as 1 by 2 plus 1. So it would be 3 by 2, right? So the power would be 3 by 2 divided by 3 by 2, and the limits obviously the limits are going to change as well, right? So what you can do instead is you could substitute this quantity back here, and you will perform the limits with respect to y only. So y varies from 0 to 1, so you could substitute this limit. So you would have 2 pi by 36, and then what was the value of m? M was 1 plus 9 y raised to power 4 divided by 3 by 2, and then we have the limits of y varying from 0 to 1. So you can now solve it. So this quantity would be, so we have pi divided by this and this cancels, so we have 18 here, and this 3 by 2 would be 2 by 3, so this would again be 9, right? So we will be left with 1 plus 9 y raised to power 4, and y varies from 0 to 1. So it would be pi by 27, and then the value of 1 plus 9 1 raised to power 4, then minus of lower limit, so that would be 1 plus 9 into 0 raised to power 4. So you can very easily solve it. So it would be pi divided by 27, 1 plus 9 minus 1. So this 1 and 1 cancels. So we have the answer as pi divided by 3. So this is the final answer.